Who is Fubi? That's improper English. But anyways, look at this quadratic function. I'm going to rewrite this guy so he looks more normal. That's by putting the negative 7x first because its exponent is the highest. This is normal polynomial standard form. And all right, so the directions say describe this polynomial function or describe this quadratic function. One of the easiest ways to describe a quadratic function is by writing it in vertex form. Vertex form looks like this. It's like f of x equals a x minus h squared plus k. So we want to have a perfect square. A number is allowed to be multiplying to it, and then we have this k just chilling on the outside watching what's going on. So how do we do that with some gnarly looking dude like this? Okay, in order to complete the square on this, the first thing you're going to have to do is make the leading coefficient equal to positive 1. Alright, so this is going to get kind of weird here pretty quickly. I'm going to put parentheses around this. I'm going to kind of push out this plus 1 like we don't care about him right now. And I'm going to take out a negative 7 from the x terms. So as I did was factor out a negative 7. And so what I did was I divided that by negative 7 and divided this by negative 7. Oops, that should be a negative 3. Whenever you factor, that means divide. Okay, so now I have my x terms right there, and it's not a perfect square, so I can make it look like this. And so in order to make it a perfect square, I'm going to have to add a plus blank. And I'm going to have to add something, add a constant to it, so that it becomes a perfect square. So let's see, where's my plus blank at? There he is. Okay, then we have a closed parenthesis, a plus 1. And now because we have a plus blank, we have to have a minus blank. Whatever you add to the side, you have to take it away so that it is still the same function. So we're not changing it. Okay, so looking at this plus 3, ew, that's kind of disgusting because you're supposed to divide this by 2 and then square it. You see, normally perfect square trinomials look like this. Boom. Well, actually, not normally, but these are just nice, cute looking ones because if you look at this 10 right here, you can divide that 10 by 2, then square it, you get 25. That 6, you can divide by 2, square it, then you get 9. That 14, divide by 2, square it, you get 49. And then 8 divided by 2, square it, you get 16. So we would have to divide this 3 by 2, then square it to get the number right there to complete the square. Now there is a shortcut here, so pay attention. You might be able to find it. If I take 3 and divide it by 2, then square it, it would look like this. And then I would get 9 over 4. So I'm going to put 9 over 4 right here. And then I have to take away 9 over 4 right here. Okay, so now what does this look like? Let's rewrite this so that we have our perfect square going on here. So this is a perfect square trinomial now. If we factor it, it would look like this. Let's see, the square root of x squared would be x. The square root of this guy would be 3 over 2. And because that's minus, I'm going to put minus right here. Now I'm allowed to factor like this because I know it's a perfect square. Then I have plus, and I have this nasty business going on. I'm going to have to find common denominators, so let's make this a 4 over 4 because 4 over 4 equals 1. Now, if I subtract 9 over 4 from that, that's going to be negative 5 over 4. And boom, there's my vertex form. Now I can describe this guy. First thing I want to notice is that this 7 is there, and it's negative. So because it's negative, I'm going to say the function is flipped. Because of the negative, and the function, I'm just going to say it to shorten what I have to write. It is stretched vertically. Okay, so the function is flipped and it is stretched vertically. That's all from that 7 right there. And then you have this minus 3 over 2 and this minus 5 over 4. And those numbers, the h and the k, this is the h, this is your k, those ones shift the function. The negative 7 is, I guess you could say that's the one that usually transforms it, like it changes its shape a little bit, stretches it or compresses it. Okay, so the h, which is 3 over 2, shifts the function to the right. Now, normally when you think minus, you think, oh, it's going to the left. No, on our graph, that would shift the function to the right 3 over 2. So it'll be 3 over 2 right here. And then this guy right here, the negative 5 over 4, moves the function down. It shifts it down. So I'm going to put, oh man, that guy's in the way. Down here, just call it 5 over, negative 5 over 2. So there's my vertex. And because we're negative, we're going down. See, it was flipped down. And it's stretched, so it should be pretty skinny. And what are we describing this in comparison to? We're describing it in comparison to the regular x squared function, which is what this guy is right here. So if we took this regular mother function right here, the x squared, we would flip it and then we would shift it and it would look like this if our function was this bad mamma jamma or this guy. They're actually the same functions. This one just looks like it's easier to explain things. All right, let me write the last stuff. I majorly abbreviated it, but you get the point. It shifted right 3 over 2 and down 5 over 2. So that's how you describe a quadratic function using the vertex form.